we know that the Fourier coefficients are given to be an is 1 over pi, integral from minus pi to pi, f of x times cosine nx dx. N goes from 0, 1, 2. Bn is to be 1 over pi times integral from minus pi to pi, f of x times sine nx dx. N goes from 1 to all the way. And of course, Fourier coefficients are associated not just with the trigonometric functions, but also associated with the function itself, right? F of x. Now we're going to perhaps assume, without loss of generality, that f of x is not only if it's given to be periodic. We can assume it has a period of just 2 pi, right? If it's periodic, 2 pi. Without loss of generality, right? So let's say if it has a period of t, any random t, we can always make simple substitution. We can let x equal to t over 2 pi times little t. Change your variable, right? Now all of a sudden f of x becomes f of t over 2 pi times little t, right? Now all of a sudden this is equal to g of little t, right? Just the notation. Now, here's my claim. G of t has a period of 2. The reason is because g of t plus 2 pi is simply equal to f of t over 2 pi, quantity t replaced with t plus 2 pi, right? And that is equal to distribute. We have f of t over 2 pi times little t plus t. Right. This is equal to what? F of x is given to have a period of t if it's periodic, right? So f of x is equal to, in other words, f of x is always equal to f of x plus the period, right? So like I said, x can be treated as a whole entity, right? As a whole entity, right? So the whole entity plus t is equal to f of the whole entity itself, right? So f of the whole entity itself, and that is equal to what? G of t, right? Of course, this is equal to, so this, like I said, we start from g of t plus 2 pi. Turns out to be equal to g of t itself. So meaning g has the period of 2 pi, right? So meaning after we use simple substitution, we've somehow turned this function into a periodic function of just 2 pi. A period of 2 pi, just to change your variable, but still the same thing, right? So we can always assume it has a period of 2 pi if it's periodic, right? So now, to prove our motivation, we first have to prove this lemma, right? So we're going to say that this lemma is, so first, pi delta mn. So delta mn is called Kronecker delta. The simple notation denotes it's equal to 0 if m and n are not equal. Equal to 1 if they're equal. If they're equal. So that means if m and n are equal to each other, we have just pi times 1. If they're not equal to each other, we have just 0. So orthogonal means perpendicular. So perpendicular meaning 90 degrees. Right? Imagine we have a plane. We have two different non-zero vectors, A and B. Right? How can we show that they're perpendicular? Right? How can we show their angle is 90 degrees? So as long as we can show that the inner product or dot product is equal to 0, then we're done. Equivalently, as long as we can show that their the length, product of length of each vectors, right, non-zero, times cosine theta, right, their angle. If we can show this is equal to 0, then we're done. Why? Because that means cosine theta is equal to 0, which means theta is equal to 90 degrees. Right? That's why we're done. Right? We can show that they're perpendicular. So we extend the concept of geometry into the space of functional space. Right? So we have a family of functions. Right? We can treat each member as a vector. Right? As long as the vectors are different, then their product, we take the integral, can always be 0. Right? Always perpendicular. Always, like every different two family members, right? Always perpendicular to each other. Right? So this is a concept from functional analysis, a very useful, very powerful concept. So first I'm going to prove this lemma. Right? Then we're going to move on to this motivation. So this lemma technique is very simple, right? For example, if I want to show integral from minus pi to pi of cosine mx times cosine nx dx, right? M and N are both positive integers, and perhaps strictly positive and also not equal to each other. Then we can say that my integral is equal to minus pi to pi. Right? What's the trig identity here? Right? As long as we have cos, we can rewrite it into, first of all, cos angle difference, m minus n quantity x. Right? Since it's cos, then we must write plus. And we write cos angle sum, m plus n quantity x dx. Right? The reason that what's going to happen is that we're going to have angle difference expanded out. Right? We have cos. Right? So minus, we have cos plus sine. We have cos minus sine. Right? Sine cancel out. We have twice of cos. Therefore, we should multiply by half. Just cancel it out. Therefore, we can easily work out this integral and this integral. Right? So what is this integral? So let me just use, like I said, they're not equal to each other. So I'm going to choose some k. Non-zero integer, k. And then work out integral from minus pi to pi of just cos kx dx. Right? So simply kx equal to t, right? Change it. So also change the boundaries. Right? Kx equal to minus pi. Right? K times minus pi. Right? K pi. What's dx? Kx equal to t. Dx equal to 1 over k times dt. Right? Constant. Right? dt cos t. All right, so everything is in terms of t. And this is very easy. So this easily turns out to be, right? So k, non-zero, so we're fine, right? So we're safe. So antiderivative sine t, evaluate from minus k pi to k pi. Right, easily just 0. Right, if k is non-zero. So as long as m and n are different, as long as they are different members from that family, right? They can always be shown to be perpendicular, right? Because their integral is always can be shown to be 0, right? In that case, right? So this is good. Right, so likewise, I'm just going to skip over the details of proving that if we have sine mx times sine nx, or we have cosine mx times sine whatever x, right? Mx, nx, whatever. So positive integer x, right? So they can, following the similar discussion, can be using similar but different trig identities, can be easily shown to equal to 0 as well, right? Perpendicular as well. So I'm just going to skip over details. And also, how about we have the same family member? All right. Same family member multiplied together, integral, cannot equal to 0. Here's why. So, minus pi. For example, if I just take m equal to n, right? Same family member. If that's the case, then we have m minus n equal to 0. Well, cosine 0 plus cosine non-zero positive integer x, right? So this is fine. This is also 0, right? So how about right? So how about cos 0? Right? Cos 0 dx, right? 1 dx. So integral, right? So it becomes 2 pi. 2 pi times half becomes pi, right? So whole integral becomes pi. So if we have the same right, cos nx, right? Turn out to be pi, right? Like I said, when m equal to n, then delta equal to 1, right? Kronecker delta. 1 times pi is pi, right? So pi. This is obvious because just related to geometry, right? Vectors. Right? The vector times itself, what's going to happen? Cannot be equal to 0, right? Dot product, right? The length of the vector itself times the length of vector itself. Square it times cos of 0 degrees. Cos 0 degrees is just 1. Right? Can never be 0. So this is obvious. Right? And likewise, we have cos nx, sine nx, right? Same thing, right? I'm just going to skip all the details. So here comes the motivation, right? So if there's a question mark, right? So if the function, a periodic function with a period of 2 pi, without loss of generality, question mark, if it can be written as the following Fourier series, half of a naught plus sum from 1. This time, let me use the index of k instead of n, just for convenience. From 1 to infinity of a n times a and b n are to be determined. Cosine n k, a k, perhaps, right? Index k, cosine kx plus bk times sine kx. All right? If it can be written as the following, then what's going to happen, right? We're going to assume that the infinite series is not only convergent, but also uniformly convergent. Right. Uniformly convergent, right? So that we can switch the order of infinite sum and integral later, right? So if we can multiply both sides by cosine nx, right? Fix n, right? Fix n, right? Fix any, some n, right? That's non-zero, right? Positive integer, maybe strictly positive integer, right? Multiply both sides by cosine nx, right? So we have f of x cosine nx is equal to half of a naught cosine nx plus infinite sum from 1 to infinity. Since n is fixed, right? So cosine x nx is also a constant. So we can take the constant inside the sum, right? So we have ak times cos kx times cos nx plus bk times sine kx times cosine nx. Right? Then we can just apply integral on both sides. So integral from minus pi to pi. Right? Integral, because this is constant, so integral from minus to pi, minus pi to pi, dx, dx plus. So integral is supposed to be taken outside of the sum, right? Somehow we can switch the order, right? Integral from inside first, minus pi to pi, dx. Then take the infinite sum, right? The reason is because we assume it to be uniformly convergent. Therefore, we can switch the order, right? So the reason we can make this assumption is that we've got to start from somewhere, right? Even without any evidence. Right? This is educated guess, educated assumption. So this time applying our lemma, right? So every two different members can be shown to be perpendicular, right? So which means we have first, left-hand side stays left-hand side, right? Minus pi to pi f of x cosine nx dx is equal to, how about this one, right? And non-zero positive integer. So cosine nx, right? Like I said previously, I've shown that. So remember, previously I used k instead of n. Right? I've already shown that the integral from minus pi to pi, for example, cosine kx, right? K non-zero, right? K non-zero positive integer, always equal to 0. Remember, I use kx equal to t, right? Then easily work out to be 0. So, but if k was equal to 0, then all of a sudden we have cosine 0. That's 1. That's 2 pi, right? So in that case, we actually have n, right? Strictly positive, right? This becomes 0 already. And how about this one, right? So the majority of the terms will become 0 because most of the time, k is not going to be equal to n, right? So we apply this lemma, right? So the only time that k would be equal to n is when k equal to n, right? With cosine nx squared, right? If that's the case, like I said, if a member times itself, then obviously we have just pi times 1, right? I've shown that. So now we have just pi, right? Pi out in here. Of course, we also have, when k is equal to n, we have an, that's a constant, right? An times pi. And also, how about this, right? Sine kx, cosine nx. Obviously different members from the family, right? Obviously perpendicular, right? Turns out to be 0, so nothing more. So all of a sudden we can just work out an, right? Divide pi over here. 1 over pi, integral from minus pi to pi, f of x cosine nx dx. Right? N is non-zero, of course. How about if n is equal to 0, what's going to happen? Right? we multiply by cosine 0 on both sides. Right? We have integral from minus pi to pi, f of x cosine 0x dx is equal to, imagine we have cosine 0x, right? Just one integral, just 2 pi times this is just pi times a naught. Right, imagine we have cosine 0, right? Replace this, cosine 0, replace that. Right, all of a sudden we have just ak cosine kx. Ak is a constant, right? Cosine kx. K is non-zero, right? I've already previously shown that this integral is just always 0, right? Non-zero positive integer, right? So this is all becomes 0. This all becomes 0. And also, like, it's always going to be different members, right? Okay, yes. So times 1, right? Bk sine kx, right? Likewise, if we have cosine kx, right? For the same reason, can be shown to be 0 easily, right? And even if cosine kx, but doesn't matter. So even if sine 0 is just integrate to be 0, but that doesn't matter. So obviously we have pi plus 0. So right. So in this case, we can also write down a naught is equal to 1 over pi times integral from minus pi to pi f of x cosine 0x. Exactly the same form. Right, same, right, n 0, right, a 0, a naught, right, the same form. So in the end, we can allow n go from 0, 1, 2, right? So this is fine, right? an is fine. So if we multiply both sides by sine nx, right? So sine nx. For the same reason, I'll just skip over the details. We can easily work out Bn to be this form. Right? The n goes from 1 to 3, right? Doesn't have to go from 0 because we don't have to worry about B naught, right? The reason is because if we have B naught times sine 0x, sine 0 is 0, right? 0 times B naught. So don't worry about B naught, right? 0 or non-zero doesn't matter anymore, right? Because already gonna, turn out to be 0 after multiplied by 0, right? It's gonna disappear, so don't worry about that. So that's the whole motivation. Right, under this assumption, right? But still we don't know if it's really convergent or not, right? But assuming if it's convergent, if it's uniformly convergent, then it has to be in this form, has to be, right? So now the question is, perhaps in a future video, right, we can discuss, so when does it converge? Under what condition does it converge, right? If it's convergent, does it converge to the function itself or not? Right? Under what conditions?